Okay. So welcome. No, I'm not going to pretend I. Okay, let me share my screen. Because yeah, this isn't to say that this is like the way to do it, but this is a way. Yeah, you see all these plots? So they have excitation temperature, and then there's a parameter, like a key parameter that they're looking at. And then they say what all of the other parameters are. And then there's just tons and tons and tons and tons of plots, which is great. But I'm thinking, in this day and age, we have access to better ways of presenting things. Um, there was also, I'm, forgive
Who
me,
is the author of the paper?
I'm trying to pronounce
98.
it. Guiber is,
Exhibition.
they're French, so I'm not sure how to pronounce that. I never know
Okay.
which, oh, come on.
78. Okay.
Because I had an idea I was kicking around ages ago, and I think I put it in here somewhere. Oh gosh, I hope there's some plots in here. Um, because I've been kicking around this idea for ages. Did I? Yeah, 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 yeah. Okay, hold on, let me get this. Okay. So this is another idea I had. Again, I was just playing around with this, where I was trying to identify trends in some observational data that I had. And so, for example, I was finding that if I did a plot of the mainline optical depth, that it tended to not just be a line, but there was kind of a wedge where I saw all of my observations. So I had some molecular excitation code at the time, and so I just selected, like I ran it on a huge number of different parameters, and I just tried to select from that the ones that fit in this wedge to see if I could constrain any parameters. And so what I had here, all of the dots on both of this plot. So there's a dot on the left-hand plot that would correspond to another dot on the right-hand plot because this is the main lines and then this is the satellite lines. And I was just trying to look at, where in optical depth space my sort the features that I was identifying were, because that's all the information I had. This is with data from the ATCA. And so all of the blue are just all of the models that I ran. And then these are histograms of, so you see in the blue, 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 blue. All the blue bits are models that I ran. And then the red ones are overplotted on top of that. And this is the distribution of the ones that fall into that wedge. And so I was just saying, can I constrain anything? All I could really constrain was sort of column density. I got a little bit of constraint with the gas temperature. But again, this was just playing around. Because yeah, I was trying to match up data that where I just didn't have enough information. All I had was the optical depth information, just trying to squeeze anything out of that. And I have a bunch of examples here where, yeah, I'm just looking at different areas of parameter space in like the main lines. So this is brightness temperature. What else was I doing? Oh yeah, this is where I was trying to match to actual observations. So I just picked out anything that was within the error bars of these points that I had. And it was, yeah, these histograms were then meant to be the thing that I would get information from. It didn't really bear fruit because I wasn't able to really narrow anything down further than, 2 orders of magnitude, which is a little bit disappointing. But I thought that kind of a visual representation was at least interesting, because then I was taking like an ensemble of data and seeing, okay, if these are the patterns that I'm seeing between these lines, that, these are the kind of physical parameters that could lead to that. I don't know. But then there's also like Radix, which is great. Have any of you used Radix?
No.
Yeah, I also used Radix.
Mm. So they had a online version. There we go. So this is great too because they have, but I almost would want to do the reverse of this because they have the parameters of the cloud and you put all of that in and then you get, and I think they have OH. Ooh, what a nice drop down. Ay ay ay. Oop oop oop. There she is. 58. Now we want one, two, two. Mhm. Where is this? Okay, so excitation, temperature, tau. Yeah, anyway. So Radix is nice because it's I think it's very easy to use, right? So I don't know, I was thinking it'd be cool to set up something like Radix, but maybe backwards where you put in optical depth, continuum, and then maybe it provides a bunch of options of what kind of environments could do that, some kind of maybe something more like this of like histograms that would be in that region, something like that. Because I think it's probably well understood by you guys. Definitely is well understood to me that you can't really say with any absolute certainty what what the gas temperature is, what the number density is. But I feel like with something like this, you might at least be able to sort of narrow it down and have a bit of a way of saying, okay, well, these densities are consistent with other measurements, or maybe the lower range of this temperature is consistent with the XYZ. So yeah, I don't know if that would take the form of a paper like the 1970 78 paper where it's a bunch of plots, or if it would be something like Radix where you can plug things in, or or what that would actually look like. Um, because then of course there's also the option of having a very, very nicely put together Python wrapper for existing code so that people can use it for their own devices. Um, or maybe all three. I don't know. I don't know. So what do you guys use like Molpop or any of those others?
Oh, yes, I used some Python wrapper for Redux,
Mm.
so it's really works, but some tuning was needed. And also for MolPopSep, we also with my colleagues try to use MolPopSep, but still have some troubles with interpreting the results which we obtained. So we tried to compare the results for the same environment and molecule between Radix and MolPopSep, and the results are quite different. So,
Yeah.
um, so
Yeah.
this is still a question why it's so different.
Yeah. I uh it'd be cool if Malcolm were here. It's not a good time for him. That's why he's not here.
Mhm.
It's I
Yeah.
I remember when I was using neither of those two things. I was using Molex is what it was called, which was code that was developed by one of my PhD supervisors, Mark Wardle. And when you're in conversation with the person who wrote it, they can tell you exactly what the differences are and what that
Mhm.
might lead to and why. But yeah, otherwise for people who aren't that knee deep in the code, it's a bit difficult. Like, for example, um the code that I used of my supervisors, it had things like electron collisions that I think Radix doesn't use. It also has an internal dust radiation field, which I don't think Molpop uses. So yeah, those kind of differences between and amongst the codes can have a significant impact on the results for sure.
Yeah, agree. And I still think that some collisional coefficients, I think maybe it's different.
No, you're right.
Maybe.
No, you're right. You're right. I think we were discussing that in one of the earlier sessions because the rate coefficients that's used in the sort of core version of Molpop, I
Mhm.
think yeah, they've been superseded with more recent um collisional coefficients and that changes it a lot. So I
Yeah.
think that um Michael Bush in his talk he compared like some side to side and he was trying to duplicate some of the plots that I think it was Ebisawa, I think it was the Ebisawa paper that used Molpop. And he was using Molpop to try and reproduce them, but he had I think the only difference in the parameters. He might have also had a difference in something like I don't know, continuum or something. But yeah, there was a lot of differences.
Mhm.
So yeah, and then of course there's the wider problem with I don't know if you've tried to use any of these codes to fit spectra because I tried really hard. That was part of the goal of my amoeba code was because I had all these observations from Arecibo, the on-off observations, which means that I could find the excitation temperature and optical depth. So I wanted to then use my supervisor's code to, instead of fitting the column densities of OH, to actually go a step further back and fit like the cloud parameters, because the molecular excitation code predicts the column densities and the levels of OH, which then predicts the observations. I wanted to take it that step back, but I found that I wasn't able to get any satellite line inversions because the line widths in my data, the features were too wide, and Mark's code includes line overlap, which is a big deal. I don't know if Radix includes line overlap. I'm pretty sure Molpop does. So line overlap is when if you have enough Doppler spread within enough velocity dispersion within your gas that photons emitted by one transition can be absorbed by a different one, and it just wreaks havoc on the excitation, and it kills a lot of the inversions and it makes everything go to absorption. But when you're looking at your data and you clearly have stimulated emission, it's like you know yeah, so that ended up being super frustrating, and all of the work that I did with his code I ignored line width because it couldn't match. And I still haven't found anyone who knows of a way or knows why that is. Um, so yeah, I guess fundamental limitations aside, I mean, would would a nicely packaged Python implementation or Python wrapper, if that was something that was so simple as to just pip install, is that the kind of thing that would make you able to use these kind of codes more?
So yeah, I just read in Zoom chat about that. MolPopSep is better for maser modeling than Radix, and I think yes, that's true because particularly for maser data, Radix I think is not very good because we didn't have some good results with Redux for modeling our Maser data.
Hmm.
So for thermal data, it's pretty good, I think, but for Masers, it's not.
Yeah,
So I agree.
that's fair. Yeah, well, as a Fortran subroutine, that would be interesting. Because that note of implementing as a Fortran subroutine, that would actually facilitate a Python wrapper as well. Because if you can have all the code as a Fortran subroutine, I don't know if this just then is going to add more layers of wrappers. I don't know. But there's what's it called? Like Fortipy? Fortipy, I think is a thing that'll allow you to take a Fortran subroutine and load it like a module in Python. And then yeah, that gives you all the flexibility of Python. Um, yeah, because then when I look at codes like Malcolm's, it took me, well, probably took me a couple of months to get it to, first of all, to get it to a point where I could run it, and then get it to a point where I could run it via Python. And I'm still not at a stage where I can actually get anything usable out of it. Because it runs, but it just produces nans, so I don't know if I'm just, I don't know. Hmm.
Yeah, it's pretty difficult um, to work with programs with codes by other people
Oh
because
yeah.
that's more difficult than maybe to write their own code. But MoPubSep is still very, very comprehensive code, of course. The
Yeah,
theory is
yeah, yeah.
comprehensive. So
And the hope would be then if more people are interested in using it, and there's, because at the moment there's I know a lot of people use it. I have no idea what the number are because, I know there's a lot of people who are like CH or other molecules who use it a lot. So the OH people, we might be a minority, but the the initial, like the original developer of Mopupset, um Andres Asencia Ramos, I don't know if 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 he has the capacity to actually add anything to it, because he's not really in the astrophysics side. I think he's more in the maths or the CEP side rather than the Molpop side. Um, but yeah, if there's I've always said like we need like 2.5 PhD students or something, some number of PhD students we need to like just fix this for us and make it work. But I think if we had a bit more of a clear set out um, brief for for a potential student or for someone, not to rewrite the code, but to wrap it in some way that makes it user friendly. I don't know.
yeah, agree. But we used for MoPubSep for modeling of H2O masers, not to OH yet, but maybe in future.
Hmm.
But for H2O masers, it's pretty good. But as I said, the results it's quite different with Redux.
Hmm. Well, I would trust Molpop more than Radix, but not to say that Radix is bad. Radix is great, but it's I think with OH it's some of its limitations show up a bit more than it would with other molecules. Um, but yeah, as you would expect, I suppose, from something with as broad of applicability as Radix. that it's not going to be perfect for everything. Hmm. Yeah, thank you, Wei, for that point you made in the chat. That's what I'm thinking actually is that it should be a talented computer science student. I think it would be better placed to do something like this for us. Because they might be able to, I don't know, have a better understanding of how all this should work, and working in consultation with somebody with the expertise and on the science side, on the astrophysics side. Because I've been considering presenting a potential project for like an honor student or maybe a master's student. Because it'd be hard, I think, to you can't really get a PhD student to do this, right? Because it's not new. It's not really PhD kind of work. I think it's more of master's kind of work. But yeah, maybe that's the ticket. Because I know they always ask for they always have calls for people to present projects for students. Maybe I could tap into the computer science department at my uni. Are you all at universities? Like, do you have access to students?
Yeah, I have an access for students, but I'm not at university, but I have some students from the university. They are working on some tasks, but not computer tasks, of course. But they are pretty good in coding. So
Mm.
in principle, I can try to give them some like a task to make a nice wrapper for MoPopSep, for example.
Mm.
So it's a good idea. I agree.
Yeah, well, maybe then if at least us, because we're the keen ones, because we're here, if we could all, make an effort to try to recruit a student, like an honors student or a master's student. Sorry, honors is kind of an Australian thing. Um, or like a master's student, maybe from the computer science side rather, or a really keen astro student. And if we sort of keep in touch with each other about our progress with that, just so we don't end up doubling up. It'd be a shame if three of us get students at the same time and they don't know about each other. Um, but yeah, that could potentially be really, really, really beneficial for the community. Because yeah,
Mm.
that's every time somebody says, "Oh yeah, I use Molpop." Oh yeah, I'm struggling to get it to work. Everybody says that, right? I can't count how many times I've heard that this week. Um, yeah, okay. So maybe that can be homework for us. Are you working in yeah, I know you're working in industry. Good. You're doing well. Good. Um yeah. Yeah, I don't know if I mean, a PhD student would be fantastic because, of course, they have a bit more time, but then, the expectation of a PhD student is that they produce something new. So I don't know if this would be good for that. I don't have funding at the moment for a PhD student, even though I keep asking for other for projects where I don't have funding. But with master's students, I think my university would be able to help. Okay, well maybe if that can then be our homework. Find somebody who can do it, but if we can keep in touch with each other, that would be really cool.
Yeah, maybe I sometimes I had been thinking on that, on getting close to an institute of research in mathematics that is just next to my department of astronomy. But, I don't know how close they are, but I think that an interaction will be good between the mathematicians and the astronomers to do
Mm,
something.
Mm.
They have programming and things like that for master degree. So I try to get in close.
Yeah, yeah.
And
Because yeah, I mean, I don't know about it at your university, but like at mine, they're always saying how great it is when people do cross-disciplinary stuff. So maybe
yes,
maybe that could be an angle that we could sell.
yeah, I think we should take advantage of that. But I don't know, in my department, they are not very interactive, let's say. We are sharing the building with the Department of Mathematics of the university, but none of us have tried to do something together. And I
Yeah.
think that we are wasting the time.
Yeah, yeah. At my old university, computer science was literally down the hall, and I never went down that hall, so why would I?
Yeah.
Yeah, okay. So maybe this can be, and I know that some of us have already made an effort to try to this go down this path of writing our own code and our own wrappers around it. Maybe if people are, I know it's not an easy thing to share your code with somebody else, because I know the way I write code, I don't want anyone else to look at it. Can kind of feel like someone seeing you in a swimsuit for the first time, but um but yeah, maybe that could be a way we could start, would be to pool things together and perhaps even have like a I don't know, some kind of a focused meeting where we can just say, okay, here's what doesn't work, here's what could be improved, but maybe something that might accelerate that process or motivate that process is if we have an interested student. So maybe recruiting a student could be an early step. Because otherwise, yeah, it just ends up being something that oh, I'll work on that next week, or oh, I'll work on that when I have time. Yeah. All right. So I put I've added you all to the Slack channel for this. Maybe this is something where we're all gonna have to come back. Uh,
Mm.
'Cause, yeah, I didn't expect to be able to solve anything today in this session. Um, but just knowing that there's a few of us that are motivated and interested in at least seeing it move forward. Um, yeah, oh, the GitHub-based community for contribution. Yeah, you're absolutely right. Yeah. Sorry, I'm just reading the chat. Um, yeah, oh gosh. But that's the thing. I mean, so many of us, like we would have benefited so much from doing an undergraduate degree in computer science, but it's so few of us have that kind of expertise and that comfort with this kind of stuff. But it's always great when there's somebody who does. Um, but yeah, and then they run the risk of overloading themselves, getting too much on. Okay, well, how about we can all try to identify or recruit students who might be able to do this. It could even be a group project. And in the meantime, in the background, we'll try to get in touch with others. And maybe we can just use this Slack channel as a way to kind of say, okay, this is why it's not working for me, or this is the part that's not working for me, and just try to at least pool what we've managed to get to work. Because I'd want to bring in I know Arshia Jacob has used Molpop a lot, mostly with CH. So I don't know if maybe the fact she's using a different molecule helps. I don't know. Um and Michael Bush as well. It's he's asleep now, so that's why he's not here. But yeah, maybe we can take that discussion offline and see if we can make some progress.
Okay.
Yeah,
Mm.
I agree. And Anita, will the Slack channel be available for a long time or just for a month or so?
It'll be available for a long time, but it's not the paid version of Slack, so the messages, I think I think it only saves like 90 days worth of content. I think that's how it
Mhm.
works. So we can still use it for forever. But
Mhm.
yeah, although I think through the University of Sydney, I think I can get a like a paid one. So if it seems worthwhile, then we can continue that. Um, but at least for the short term, yeah. For the short term,
Mhm.
it'll work. But yeah, I wouldn't worry about that too much. I can find other options if we want something a little bit longer term.
Mhm.
Right.
Okay, thanks.
All right, so let's stay in touch on
Okay.
that.
Okay.
And thank you all so much for this is the last session.
Oh,
Okay. Thank you,
I'm
Anita,
going
for
to
this
miss you.
very cool marathon.
Thank you all so much for attending and not just this session, but just in general. It's been so cool that other people that I didn't even know because the initial invitation was just the people I knew and it's spread out beyond that, which is just so cool. So thank you all so much for coming to the workshop.
Thank you.
Okay.
Yeah,
No
thank
worries.
you.
Nice to see
Let's
you,
be in
Hiroshi.
touch.
See you. All right, take
Bye.
care,
Nice,
everyone. And
nice
we'll
to
keep in
hear you,
touch.
Nadia. Bye.
Nice to see you, Sarah.
Yeah,
Again,
bye.
sorry for turning off my camera. I cannot turn it on
Don't
currently.
worry, it's too early for you.
Oh, I'm gonna go take a nap.
Sorry.
Okay, bye.
Okay,
Bye bye. Thank
Have a
you.
bye.
nice
Thank you.
evening, Anita. Bye.
Thank you. You too.